you should not do that from the reading side of that channel. Okay, that said, I'm going to go through my talk. How much time do we have? 30 minutes max. Yeah, okay, I don't need that much. So that's the link to the slides. I'm going to link it again at the end of the presentation. A little bit of introduction. I work for Google in the security team. I work on web security, and today I'm not going to talk about it. I already bothered you enough last time that I was on this meetup. I'm going to talk about fuzzing. Fuzzing has this long definition. You actually don't need to read through all of that, but the general idea is that you test your program without knowing what your program does. You just throw random data at it, and every time you find out something new, and I'll discuss what new means, you just keep the input and you say, okay, this program accepts this input, let's move on. Why fuzzing? Can everybody read these slides? Okay, good enough. Half of the room replied yes. So humans are terrible at finding edge cases, because when you write your code, you write your tests, right? You should write your tests. And you have your code in your mind. So you're following some kind of rules that are not said and are not in the code, but you expect some kind of input to respect some kind of rules. You work under assumptions. Those assumptions are not in the heads of your users, but most importantly, they're not in the heads of your attackers. This is always something that you have to think about. And one more reason to random testing or fuzzing, which are slightly different, is that they're proven to be effective. And one thing that really bothers me is that people think that fuzzing is just an advanced, complicated tool for hackers to use, which to me sounds really weird, because I've always seen fuzzing as just another way of testing. So when people tells me, do you do integration testing or unit testing or fuzz testing, for me they're on the same plane, but apparently it's not for everyone. And I have to break you some news. If you don't fuzz, your attackers will. So this is weird to me when people say, yeah, think if someone ever said, yeah, you know, unit testing is just for hackers. Why would you do that? It just, To support fuzzing, you should write fuzzable code. Fuzzable code is usually easy to unit test, and if you write code that is hard to unit test, so there should always be a way to execute just your code. If you try to fuzz too much, you're going to incur into some problems, and if setting up your fuzzing environment, like your test environment, takes too long, your fuzzing is going to be ineffective. Think about a web server. You don't want to spin up the entire HTTP server to just send some random text, see, oh, this is not a valid HTTP request, let's spin it, let's shut it down. That is going to take ages. You just want to take, for example, the request parser and throw the text at it. You don't bring up sockets, you don't do syscalls, you just run the data through your code. And your code should be stateless. If you're fuzzing stuff that depends on the state, you'll get some crashes. You will always get crashes, and you will not be able to reproduce them. So you will know you have a bug, but you don't know where. I don't know if you like that feeling. I personally don't. But I know, it depends on what you like in your life. I like to sleep. And here we see the first difference about random testing and fuzzing. Fuzzing uses coverage information. go-fuzz, which is the tool that I'm going to talk about, but now the Go compiler has some tweaks to use other fuzzers, rewrites your code. Every time there is a branch, like an if or a for loop, it adds a little bit of code to say, I got here. And it feeds random data to your program, and let's say it says, okay, I covered 17 branches. And then it feeds more random data, and it says, oh, I covered 20 branches. This new input that I found is somewhat related to the code I'm testing. Keep in mind that fuzzing is black box. So it keeps that piece of data into a folder called corpus, and is going to run over it and modify that new found string to explore more your code. So this is going to explore in a smart way all your code. And if it finds some constants in your code, like strings, it's going to try those out. Because it says, okay, if you're using a constant here, why? And also, why is this a special value for you? So if you take, for example, a JSON parser, and you instrument it with fuzzing, you're going to see a lot of braces in the input, because that's one of the tokens it accepts. And if you fuzz HTTP, after a while in the corpus directory, you will see some stuff containing, for example, get in the body, because why not? I mean, it's a valid token. Fuzzing doesn't know what it's fuzzing for. One very important thing is that fuzzing tries to suppress duplicates. If I find that your library has a problem, for example, it doesn't parse long strings, and I feed it a gigabyte of data, and then I feed 2 gigabytes of data, I don't want those crashes to be duplicated, because it just makes it harder to debug. And go-fuzz has some smart ways to deduplicate crashes. Most fuzzers do, and sometimes they fail, so you get tens of thousands of crashes per second, and your computer blows up. And, well, yeah. That said, let's get to the practical part, which is the good part, not too much about theory. So, you want to pre-check your input. The fuzz function that you're going to implement accepts a byte slice. That's it, full stop. If you know that your program will never accept a byte slice that is longer than 5 bytes, just straight away reject anything that is longer. That is just going to tell the fuzzer, be faster and just don't feed me useless data. And this is important. When you call your target, the input that you feed to your target needs to be a direct derivation from the input that the fuzzer gave you. So if the fuzzer gives you a byte of value 10, maybe you want to feed 100 to your function, and we'll see how to transform the input later. But if you feed it 10, it should always be 100. There is no random derivation. This should never happen, or again, you will not be able to reproduce your bugs. You need to inspect the return value of your function. I mean, you can fuzz at random, just throw data at a parser, and if it panics, you found a bug. Good. Nice. But maybe it just never panics, but it gives you random data in output, or broken data. You don't just throw random input in your function, you should validate some invariants. And then in go-fuzz is one of the few use cases in which I'm allowed to panic as much as I want, which is nice. So every time something unexpected happens, you should panic. That's what tells go-fuzz something wrong happened. And if you don't panic, you have to return an integer, which is one of these 3 values. This is how it looks. You have to implement one function, takes a byte of slice, returns an integer. You might want to transform that byte slice. It's fine, you don't have to. And then you call fuzz target, which is your function, the one that you don't trust, or, well, if I wrote it, I usually don't trust it. But in the general case, any function that you don't trust. And then if something unexpected happens, you panic. If you think this input is relevant, you return 1. For example, if your parser returns a value and an error, and you got an error, who cares? Your parser just doesn't accept an input. But if your parser didn't return an error and returned valid data, just return 1. Instruct go-fuzz and tell it, this input is important. You discover something new. Otherwise, if it is something completely useless and you want to tell go-fuzz, never give me this again, you can return -1. I never use this, and I think you shouldn't either, but if you find a good use for it, go ahead and tell me. Comments are opened on this slide. Don't deny of service me, please. And then, if it's not interesting or not too uninteresting, return 0. To run this, you can't use the default Go tool. As I said, you need to instrument your sources, rewrite the sources, so you use an external tool, and you run just a couple of commands. And now I'm going to demonstrate how to do this. This is the wrong file. This is my function. So I decided to write a codec because codecs are easy. This codec takes a string and returns an integer. If it can't parse it as an integer, it returns 0. It's a safe default. I mean, 0 is nice, it's all round good. And then I write a serializing function, which is write, that takes an integer and returns a string. I mean, this is an easy thing to implement, right? I mean, how could you possibly get that wrong, right? So I wrote unit testing for this. I considered several cases, like 42, which is important. A string just returns 0. A negative number, I thought about this. A negative number returns a negative number, 0 returns 0, and a floating point, that's not really a valid integer, isn't it? So I just return 0. Good. Run the test pass, my code is correct. This is usually where I stop. I think where everyone stops, and this is not nice. Because let's say that I take this fuzz function and I just call my functions. So I read the number, I just treat the input slice as a string. If the number is 0, it's probably random data I don't care about, so I just return 0. I don't care. This is input I don't care about. And then I write the number again, and I compare the two strings. Ideally, if I read 17 and I write 17, they should be the same string, right? So, I'm going to build these. I'm in the wrong directory. So I'm going to build this. You need to use the special go-fuzz build command, and then I'm going to run go-fuzz. This is going to spin up my CPU, and it found a crash. You see, this is saying crashes 1. That crash is probably this panic. So let's take a look at the output files. When you run go-fuzz, it's going to create 3 directories: corpus, crashes, and suppressions. Corpus is going to contain some data that it fed. These are the hashes of that data that it used to discover more code, as I was saying. But let's take a look at the crash. 08. So if it starts with 0, I'm going to serialize it at 8, because, of course, it starts with 0. So this is one crash. I let it run for how long? A few seconds. And it already found a crash. There are 3 more bugs in this code that I found by running it for 10 minutes. For example, if it is too long, it will overflow. If it is minus and then a 0, it will also not serialize that 0. There are several bugs. It's like 7 lines of code. That proves 2 things. Fuzzing is effective and found stuff that you wouldn't expect, and I'm very bad at unit testing. Now, checking invariance doesn't stop at serializing, deserializing back a value. You could also check, for example, if you get an error, the other value should be nil. You don't want to return 2 valid values. Don't do that. Unless you specifically document it, or you're implementing IO writer or IO reader, don't do that. You could check the numbers didn't overflow. That is also a possibility. There is also the possibility of using a reference implementation. We'll see this later. If your package has a state, you could save the state before fuzzing, fuzz, and check that the state hasn't changed. If you expect your function to be pure, the state shouldn't change. And also that there were cleanups. For example, if your program creates temporary file, check there are no more temporary files after your function is done executing. Inspecting a crash it gives you 3 files, go-fuzz, every time it finds a crash. One is the mere input that you can feed your function to reproduce it. One is the quoted input in a Go quoted way. You can just copy it, paste it in your sources, and it's going to be valid. Sometimes you get invalid UTF as input and makes your function crash. It's almost always the case, so it's good to have the quoted thing. And then the output of your program with the panic and the stack trace. This makes it way easy to understand. Question for the public. So, for the audience, what do you think is the quoted thing for? What's very useful and infinitely valuable about the quoted part? Yeah, so every time you find a bug with go-fuzz, take that string and put it in your unit tests. This is very important, because if you made a mistake, probably the next person that changes your code is going to make the same. I mean, you know your code better than them, supposedly. Sometimes go-fuzz starts finding too many crashes. If that happens, stop it. It doesn't make sense. If you have too many crashes, you can't manually go through them. You should change your strings or your stack traces or clean your stack traces before you panic, because that is going to be impossible to debug. And also, while go-fuzz runs, it gives you a coverage value. If the coverage goes beyond 5,000, some hashes are going to start colliding and it's going to lose of efficiency. So you might lose visibility on some bugs. So if you get to that value, you might want to change the function you're fuzzing to a smaller one or to one that doesn't depend on that many things, because otherwise you just don't get valuable output. If you get out of memory, crop your input or just write your code better. Try not to get that, because that panics every time if it goes out of memory. It's probably going to be a denial of service on your server, and in any case, you should limit your inputs in your function, especially if they accept untrusted input. This is what I was talking about. Every time you find a crash with go-fuzz, even if it doesn't make sense for you, put it in your unit test. So you're sure that you're not going to make that mistake again, or someone else that touches your code. This is interesting because I found this in a public guidance on what to fuzz. Code that accepts complex inputs, those are usually parsers. If you think that JSON is not complex, we'll see an example in a bit. I mean, integers have proven to be pretty complex, so that is going to be fun. And also, not just stuff that accepts random or complex inputs, but also stuff that goes through complex states. If you have a big state machine, even if it accepts a small, supposedly simple input, you might want to test this with fuzzing. Untrusted inputs. I work in security, as I said, and this is fun because every time I see someone taking something from a database and passing it through functions, I'm always like, did you sanitize this? But it comes from an internal database. Who writes to that? Do you have any idea who writes to that database? And so this is usually most of the input that you should test, not just because you find vulnerabilities with it, but also just bugs. And third-party code. If you have third-party code, and you probably do, you shouldn't trust it. So just fuzz it. Not because people are untrustworthy. If they put a backdoor in it, you won't find it with fuzzing, but just maybe because the package is not reliable. So let's take a look at it. I'm going to talk about HJSON, human JSON, because we needed another JSON for humans, because JSON were made by aliens. I'm really annoyed by the amount of JSON parsers that are out there. What I'm going to do here, I'm going to create a value, and marshal data into it, the data that I got from the fuzzer, marshal it back. If I can't marshal it, but I just unmarshaled it, that's wrong. I mean, I read it, why can't I write it? I mean, I'm dyslexic, but my code is not. So, and then I'm going to take another value, and marshal it again, and I'm going to compare those values. So, you give me A, I marshal it back, and I expect the two representations to be identical. In this case, I'm not using reflect.depequal, but fuzz.depequal is a simpler form on a smaller package. This is what I was talking about. If you import reflect, you're going to import a lot of branches, and it's going to take ages to compile. So the go-fuzz corpus fuzz package provides utilities to make fuzzing easier for you. In this case, I ran this fuzzer for about 5 seconds, and I found 2 panics. Now, you're going to see all my history. Beautiful. Now, there shouldn't be more bugs because I already reported them and people fixed them. So, comic relief. Okay, so, interesting. So, they fixed some, and they introduced another. Beautiful. So, going back to the fuzzing bit, I'm going to report this later. To write this fuzzer, I just took fuzz function from the corpus package that fuzzes the JSON, standard JSON package, and I simplified it. After all, HJSON is a subset of JSON, kind of intersected set of JSON. So it took the code, I copied the corpus, and I let it run. And it found 2 crashes that have been fixed. The corpus, you don't have to overdo it. You can pre-populate that directory. So for example, if you're fuzzing JPEG, it's going to be useful to put a JPEG in that directory because JPEG is a quite complex format, so you can help the fuzzer out. Don't put 12 gigabytes of data in there because it needs to read it. And it can figure out most of the stuff. After fuzzing the HTTP package for 10 minutes, I found perfectly written HTTP2 requests for it. So it's pretty good. I don't know if you've ever seen an HTTP2 handshake, but it's... So, fuzzing stuff is not a parser because so far they were just serialization and deserialization. A colleague of mine was bored because DNS requests took too long and they were unencrypted. So, if you do a DNS request, it's going to go in the clear to your ISP, which is able to decode it, which is bad. And also it's going to be slow, because most of the time you're going to hop through several DNSs. So he said, is it really that hard to write a DNS proxy? Spoiler, it is. And at one point we hit a problem, we need to cache. Most caches are good for general purpose stuff, not DNS. In the DNS case, you're going to resolve a set of domains over time, every day, and they're very likely to be requested again. But in some days, you're going to request one domain for the first time, you're going to request it like hundreds of times a day. Like because you're looking for a house for the first time in months or stuff like that. So I wrote a custom cache, said decision. And it was so complicated that I didn't trust my unit test, so I decided to fuzz it. But go-fuzz gives you a byte slice. So what I did was create a translate function, which is this one, that takes a slice of bytes and says, okay, if it is too long, too many operation, it's just a cache. I don't care, just discard it. If it is too short, I mean, it's a cache, so I need to like at least do a put and a get to see what happens. So reject it again. And then I decode stuff. So I decided that keys would be 4 characters and values would be 4 characters. And a byte would give me either a get or a put operation. I'm too short. And this is what I used to translate. And the fuzz function does what is called a differential fuzzing approach. Differential fuzzing says, let's take an implementation of your code that is maybe slower or just dumber and compare it with your actual implementation. Like when you optimize your code, you want to keep the old version, the new version, fuzz them together, and if there is any difference, you didn't really optimize, you just break it. So for these I used a map, because a cache is after all a glorified map. And I threw the same get and put request at both implementations, my cache and the map. If something was in the map and was not in my cache, and my cache was not full, that wasn't due to eviction, that meant my cache did something wrong. And so on. So I assumed the Go map implementation was correct. That wasn't true for the HTTP package, so be careful on what you differentiate on. And then I just used it. I used the cache and the map, and I decided to assert a lot. If you see, this die is just a decorator for a panic, and I do it a lot. Any assertion that fails makes me panic. And I found a bug that required 12 sequential operations to make my cache misbehave. I would never have found that with unit testing. Seriously. Maybe even with use, I wouldn't have found it, because it requires some get input and then another get that would refresh the value, and then another put of another value, and I really didn't remember. I just put a string, it worked. One thing that is important, if you have a translation function, like this one, you should really write a small program that repros your crash, that takes your input from the corpus and translates it to human-readable things. Because otherwise you're going to see a blob that doesn't really make sense. You want a program to decode it for you and give you in a human-readable format. This is only necessary if you have a translate function. There are some experiments to make fuzzing better, like fzgo tries to accept structured data. Like you, instead of accepting a byte of slice, you say, I accept this struct, fill it with random data. So if it has an int, puts an int. If it has a string, puts a string. It's experimental, but it works pretty well. So it also has an experiment to automatically generate fuzz targets for you to use. That works not as good, but it is still worth a try. Now, how long does it take to fuzz? Forever, literally. After fuzzing OpenSSL for 1.5 years, I'll let you decide if it is 5 months or 6, they found a bug, and they were fuzzing on pretty beefy machines. These might seem like discouraging, but to be fair, the most bugs that they found through fuzzing were found in the first 5 minutes. So you should at least start fuzzing. And if you don't want to fuzz on your machine, you might use cloud services that I'm going to talk about. Chrome supports fuzzing. Just to give an example on what is being fuzzed nowadays. But they didn't update their tests when they added the last element. They added the portal element, they forgot to change the fuzz target. So some hackers did that for them. Good of them. And they won 8K by just reporting to memory corruption vulnerabilities. So as you update your unit test, when you change your code, update your fuzz targets. Because if you add functionality, it should be fuzzed too. Also, portal element, bad idea on so many levels. If you don't want to fuzz your machine and you have an open source project, Google offers machines for you. Google just gives you some CPUs to fuzz your open source project, and if you find bugs, it will report them to you and sometimes give you detailed information on how to debug it. If you use Go, this is a direct link to the documentation on how to do this with Go. So at this point, I would like to ask something, which is, why are you not fuzzing? If you ever an answer for this, if you're already fuzzing, good of you. If you're not fuzzing, I would like to know your answers. And for anything else, this is my Twitter, these are the slides, and if you want fuzzing to become part of the Go command, please upvote the issue. Thank you.
Awesome. Questions? You could take some questions?
Yes. Questions or answers.
Yeah. Or someone can fuzz in constantly for the next 5 minutes?
You can feed me random data. Let's see how I reply.
Hi. Tickets, will that make fuzzing work with modules as well? Because at the moment, go-fuzz.
So it didn't used to work, but it now does. So I tried with very simple programs, and it works. There was one of the latest PRs that were accepted that enables fuzzing on modules, and it actually came from the author of fzgo. So it kind of supports modules, because once it recreated a separate Go path for you and rewrote the sources there, it didn't work with modules, and now it uses the module information to create that Go path. So it's kind of a hybrid approach. I don't know where it fails. It should work for most cases.
When do you fuzz?
So the question is, when do you fuzz?
Do you do it CI or do you do it?
So not on your CI. You don't fuzz on your CI because otherwise you're going to use it too much. You should use a separate infrastructure for fuzzing. But when do you fuzz? Always. Especially if Google is paying for it with OSSS fuzz, just let it run. So especially if you have untrusted input fed to very complex functions, just fuzz. Or be better at unit testing than me.
How close does testing quick, that testing package, get?
So I get that question a lot. Testing quick is random testing. So it doesn't do coverage. It's going to feed random data, and sometimes it's going to find crashes, but it doesn't know about coverage. So for example, if you test the HTTP package with quick, you're not going to find anything. If you test the HTTP package with fuzz, you're going to discover new HTTP methods you didn't know about. Number for all will amaze you. And sorry. So quick is a very simple form of fuzzing without instrumentation and without a feedback.